Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Did you remember what were we discussing yesterday? I think we were discussing about IR spectroscopy. In that we have discussed the alcohol and the ethers. Alcohol and ether, how we can distinguish alcohol from ether just by mentioning the signal due to the OH tracing frequency, and another one is due to the CO stretching frequencies, and these are two strong peaks observed in alcohol, whereas in case of the ether only one noticeable peak or band is observed near 1100 per centimeter due to OH due to CO stretching frequency, and in ether the upsend of band in the range 3200 to 3600 per centimeter will be absent. This clearly indicate that there is no alcohol present in the above structure. So in this way we can very easily distinguish the two structure from each other by using IR spectroscopy. Now today at present what we are going to discuss, listen here, third point which we are discussing, that is a alkylation. See, it's called as a alkylation. Alkyl halide, not the alkylation. Alkyl halides. So that is not, this is a process, alkylation is a process, but here is the alkyl halide. Alkyl halide. So that is the point of discussion. Now, as we know that the definition similar to as what we have described in case of alcohols or the ethers, these general formula of alcohol and the ethers are ROH and the ROR dash. Similarly here, alkyl halide generally represented as RX. And the definitions of alkyl halide, the organic compound having general formula RX is known as alkyl halide, where R may be as a aliphatic compound or the aromatic compound, and halide X is called as a halogen family members such as fluorine, chlorine, bromine and the iodine. These are the element, halogen family element, and when they are present in the organic compound, that compounds are generally known as alkyl halides. Alkyl halide, it becomes as a functional group, and that functional group, as we know that it shows the characteristic absorption peak or band or signal around 500 to 800 per centimeter, or maybe 1100 per centimeter, clearly indicate that there is a presence of halides in the organic compound. Let's see here the strong absorption of halogenated hydrocarbons arise from the stretching vibration of, generally stretching vibration of CX bond. Aliphatic CCl absorption is observed between 800 to 600 per centimeter. 800 to 600 per centimeter. Carbon tetrachloride, as we know that CCl4, which is known as a carbon tetrachloride, it gives the prominent or noticeable peak around 797 per centimeter. Remember, this is a noticeable peak observed in IR spectra, and from that organic chemists immediately come to know that there is a carbon tetrachloride is present over here. Carbon tetrachloride CCl4 shows an intense band around 797 per centimeter. Brominated compound absorb in the range 600, there is a CBr around 600 to 500 per centimeter, while iodo compound in the region 500 to 550 per centimeter. Let's see over here. Suppose we have RF means fluorine, R, Cl, then R, Br, and R iodine, or we can see their aromatic compound Cl. Suppose these are the sum of the compound which I have written here or drawn here. Let's see the peak due to the carbon halides, and when there is a CF stretching vibration, the peak absorption peak appear around is 1400 to 1000 per centimeter. So this is the characteristic of presence of fluorine in the organic compound. 1400 to 1000 per centimeter clearly indicate that there may be fluorine present in the organic compound. Let's see here the alkyl chloride, if it is present, the peak is appear around 800 to 600 per centimeter, which is a prominent peak observed in a organic compound if there is a chlorine atom present. And suppose there is a bromine compound, bromine element or bromine atom present in the organic compound, the peak will be observed around 600 to 500 per centimeter. 600 to 500 per centimeter shows or indicate or suggests the presence of bromine atom in the organic compound. Next would be, if there is a organic compound contains iodide, the IR absorption peak appear or the band appear around 500 to 550 per centimeter. These clearly indicate that there is a possibility of presence of iodide group, and if that halide or the generally as a chloride, chlorobenzene, the peak would be appear around 1086 to 1096 per centimeter, which is a characteristic of chlorobenzene, which is observed around or near about 1086 to 1096, clearly shows that there is chlorobenzene or the chlorine atom present or attached to the aromatic moiety or the aromatic ring. So the appearance of absorption peak at 1086 to 1096 per centimeter shows the presence of aromatic chloride in the organic compounds. And if you observe these structures and IR absorption peak, or these are the stretching frequency, you will observe there is gradual increasing or decreasing IR frequencies if you move from right hand side to the left hand side. In the present situation, you will clearly observe there is gradually decrease in IR frequency. If you move from right hand to the left hand side, you will observe there is a gradual trend of increasing IR frequency. So by knowing the exact peak of IR band, from that we can identify what type of what kind of or what sort of functional group present in the organic compound. A strong CH2 vagging band is observed for the CH-6 in the region 1115 to 1300 per centimeter. Chlorobenzene just I have mentioned here, just now I have mentioned here, chlorobenzene absorbed in the range 1089 to 1096, 89. So remember here 1089 to 1096 per centimeter. The effect of halogen atom is also seen on the stretching and bending frequencies of CH bond. And now here the figure 6.6 illustrate or explain this effect for 2-bromopropane, that is isopropyl bromide, and the IR spectrums are shown over here. Let's see how it looks. And generally we know that the IR spectra generally represented absorption versus frequency or wavelength, and the spectra generally looks like here. This will be the peak observed over here, and then it gives one peak around here, and then there are no, the peak is not here. Now then at this position there may be such kind of the peaks are observed like this. This is a IR spectrum for the 1-bromobutane, 2-bromobutane, for example CH3, CH2, CH, here Br and the CH3. This is a spectra for the here wavelength 2.5 to 1600, and the frequencies are started from 4000 per centimeter to 625 per centimeter. These are the values, and the IR spectra looks like this. If you observe these spectra carefully, and these peaks, this generally is around due to the CBr peak, and this peak observed here due to the CH peak, and every organic compound produce this peak, and therefore it is not useful peak as far as organic chemist point of view is concerned. And here clearly the peak observed around 600 to 500 per centimeter, that clearly indicate that there will be a presence of bromine atom in the organic compound. So in this way we can clearly understood the IR spectroscopy. It is a very helpful for the organic chemist for the structure determination. That is every spectroscopy has its first application. It provides the wealth of information about the structures, and as we know that if you know the structure, we can able to predict its physical as well as chemical property of that particular organic compound, and therefore these all are that's why we are studying this type of the organic chemist. Now let us see the next point which we are going to discuss here is very important. Most of the question would be offering from this point which we are right now going to discuss over here. So let's see what's that point. That is a carbonyl compound. D point is a carbonyl compound. Is a carbonyl compound. Carbonyl compounds, and as we know that carbonyl compounds are generally present in number of organic compounds, commonly carbonyl groups present in aldehyde and the ketone, and that type of the compounds are generally referred as carbonyl compounds. And when this carbonyl compound present, it gives the prominent peak near 1700 per centimeter. So that is a clearly indication of presence of carbonyl group, because if you observe the spectra of organic compound which involve carbonyl group, the spectra very clearly shows very strong band or the peak or the signal appear around 1700 per centimeter by looking its size or shape. Organic chemist within a minute they recognize the peak, identify that peak, and that peak is due to the presence of carbonyl group, because it has definite the shape and size, and therefore while interpreting that IR spectra, the organic chemist easily identify those peaks very easily. Now let's see what are the carbonyl compounds. Generally there we know that suppose there is a CHO or maybe C double bond O or COOH, then C double bond OOR, or maybe C double bond O NH2, etc. If you observe these functional group, every functional group commonly contain the carbonyl group. Let's see, here I am similar to in a previous point we have described the definitions of alcohol, aldehyde, alcohol, ether, alkyl halide. Similarly, here I am going to represent some of the structure. Observe the structure carefully and now tell me what is that, what is the name of this compound. General, it is an aldehyde. Aldehyde, this is the structure of aldehyde. Let me draw one another structure, C double bond O R dash. You can clearly understood this one. What is that? This is a ketone. Very right. Another one which I am going to write over here, C double bond O OH. This also you are familiar with these structures, and this structure is acid, very well known. These are the general formula I am writing. And now when there is a R C double bond O OR, then that will be the ester. So these are the different structure which we have written on that on the blackboard. You can see there is a common point in all those structure, which is carbonyl, and that's why they are referred as a carbonyl compounds. Now let's see another one, R C double bond O, then NH2, which is known as amides. Then before that, let me draw one more structure which I have forgotten, R C double bond O X, that is a acid halide, and now R C double bond O NH2, which is known as, very well known as, which is a amide. And let me draw one more structure over here, R C double bond O C double bond O R, which is called as a acid anhydride. Again, one is a lactam, lactone, that is not at this level we are not going to study, because that is higher study. When you go for MSc, then you can study that type of the compounds. So these are the some well known we have studied up to Sy/Bsc, or even though this year. So these are the general structure I have written over here, and name also written over there. So these are the general formulas which we have written over here, and in all these compounds, near about 7 compounds which I have written over here, you will observe there are common thing, which is carbonyl compound present in each and every structure. Now let us define aldehyde. What do you mean by aldehyde? The same definition, or the remember, it is the easiest way to remember those organic compounds by defining in a similar fashion or in a same way. The organic compound having general formula RC double bond OH is known as a aldehyde, and we know that the special characteristic of that aldehyde, where R may be aliphatic or the aromatic, and here you always remember one point over here, aldehyde group always present at the end of the carbon skeleton, or we can call it as at the end. The aldehyde group is always present at the end, and that's why, and the functional group present in the aldehyde is a C double bond OH, CHO, sometimes it is written as. So that is the carbonyl group here also as a present. If you move on to the next one, which is also the structure is written RC double bond O R dash, the organic compound having general formula RC double bond O R dash is known as a ketone, where R and R dash may be alkyl or the aromatic compound, and the carbonyl group, it is present commonly here in the ketone structure, and which is known as a functional group. And why we call it as a functional group? Remember, functional group is nothing but as a site of reaction. Whenever we adding the reagent, the changes are occur at a particular part of the organic compound. That part is known as functional group. Carbonyl is a common group present over here in case of aldehyde as well as ketone. Now if you see another structure carefully, that is RC double bond OH, which is acid. Here also we can define the organic compound having general formula RC double bond OH is known as acid, where R may be aldehyde or ketone. Here R may be aliphatic compound or the aromatic compound, and now the C double bond OH is referred as functional group, or it is known as carboxylic group. And this carboxylic group is an functional group. And if you see another one, ester, acid halide, amide, acid anhydride, these all are the derivatives of that acid. Ester, how will you prepare ester from acid? Just by acid treated with alcohol, the catalytic amount of the acid is required. There will be the continuous process for esterification, and the resulting compound form is called as acid. So in this way we can obtain or we can synthesize ester starting from the acid. Here in a definition, ester, the organic compound having general formula RC double bond OR dash, is known as a ester, where once again R and R dash may be same or different, may be aldehyde or aliphatic compound or the aromatic compound. That let's move on to the next one, which is acid halide. Acid halide, it is also one of the derivative of acid. If acid treated with thionyl chloride SOCl2 or PCl5 phosphorus trichloride or phosphorus pentachloride PCl5, these are the some of the reagent. From that we can get the acid halide, and acid halide also known as a derivative of acid. And the organic compound having a general formula RC double bond OX is known as a acid halide, where R may be alkyl, aliphatic or the aromatic, and where X may be fluorine, chlorine, bromine or iodine. As we know that these are the halogen family members or those elements. Now move on to the next one, which is also as a derivative of acid. How do you get that amide? Just by acid treated with ammonia heated, the resulting compound obtained will be the amides. And next one, the acid anhydride. The acid anhydride, it is also one of the derivative of acid. And that how would you prepare this acid anhydride? It is also as a acid generally heated at high temperature above 200 degrees centigrade or more than that, in presence of Al2O3 aluminum trioxide. The resulting compound obtained is nothing but as acid anhydride. These are the general trends which we have learned over here. Now this is one of the important point as far as exam point of view is concerned, and therefore let us see how do we differentiate aldehyde from ketones. If you observe this, there the commonly of the 1715 per centimeter, so 20 per centimeter carbonyl group, and here you will find 1715 per centimeter. because aldehyde as well as ketone both containing the carbonyl group, and therefore the strong and the noticeable peak or the characteristic absorption peak appear around 1700 per centimeter. It is a slightly 1720 and 1715 per centimeter observed clearly indicate that the compound is a carbonyl compound. But if there is a aldehyde here, in addition to this, aldehyde shows one peak around 1715 to 2850 per centimeter is an additional prominent peak observed in a IR spectroscopy, and from that we can easily distinguish between aldehyde and the ketone by observing the IR spectra. If the peak appear around 1720 or 1715 per centimeter, clearly suggests that there is a carbonyl group is present. But whether it is aldehyde or the ketone, you can see another prominent peak is appear around 2750 to 2850, clearly indicate that this is this stretching frequency is observed due to the aldehydic CH. I think with this we have discussed, these are the some of the point. So remaining point we will discuss in our next lecture. With this, let us stop today here. Have a nice day. Thank you.